Hello everyone, I am Nivedita Jana from Ambika Prasad Research Foundation. Welcome to all of you to our channel Biodiversity and Conservation. So today our topic is about the Environmental Science Part 6 of Unit 1, which is about the mass and energy transfer across various interfaces and different systems. So let's start. First we are going to discuss about the systems and surroundings. A system that is delimited from the surroundings by real or hypothetical boundaries is known as a thermodynamic system. A thermodynamic system refers to that part of the universe in which observations are made and the remaining universe constitutes the surroundings. The surroundings contain everything other than the system, and the system and surroundings together make up the universe, in which we can say that the universe is equal to the system plus the surroundings. And the thermodynamic system is embedded in its environment or surroundings through which it can exchange heat and work on. It exchanges the heat to its surroundings through a boundary. The boundary is the wall that separates the system and the environment. Thermodynamic systems can exchange energy or matter with the external environment and can also undergo internal transformations. So, the system boundary is a closed surface surrounding a system through which energy and mass may enter or leave the system, and the surrounding is everything that interacts with the system. And the system is the region containing energy and matter that is separated from its surroundings by arbitrarily imposed walls or boundaries. For example, in a car, the engine burns gasoline inside the cylinder and is considered as a thermodynamic system. The radiator, piston, exhaust system, and air outside from the environment of the system. The inner surfaces of the cylinder and piston are considered as the boundary. So there are three types of systems in thermodynamics, which are classified as open systems, closed system, and isolated system. So the open system, if the thermodynamic system has the capacity to exchange both matter and energy with its surroundings, it is said to be an open system. One example is, let's consider a beaker in the presence of reactants in an open beaker. Here the boundary is an imaginary surface enclosing the beaker and reactants. And the second example is a steam turbine, a pool filled with water, where the water can enter or leave the pool. And in open system, matter plus energy can be exchanged. And a simple example is boiling of water in open vessel. Then the second one is closed system, a system which has the ability to exchange only energy with its surroundings and cannot exchange matter is known as a closed system. For example, reactants placed in a closed vessel made of materials like steel, copper, and silver are an ideal example of a closed system since the material of the vessel is conducting in nature. A cylinder in which the valve is closed is an example of a closed system. When the cylinder is heated or cooled, it does not lose its mass. So simply, in closed system, energy can be exchanged but not matter. And another simple example is boiling water in a closed metallic vessel. Then the third one is isolated system, a system which cannot exchange matter or energy with the surroundings is known as an isolated system. The zeroth law of thermodynamics states that thermodynamic processes do not affect the total energy of the system. For example, reactants are present in a thermostat or an insulated vessel where neither energy nor matter is exchanged with the environment. And another example is if the piston and cylinder arrangement in which the fluid like air or gas is being compressed or expanded is insulated, it becomes an isolated system. So simply we can say in isolated system neither matter nor energy can be exchanged. Then the matter balance, which is also known as mass balance, which is used to find the accumulation of a contaminant or pollutant or substance in a particular region, and those particular regions are also called as control volume. And the mass balance equation, the accumulation rate is equal to input rate minus output rate plus reaction rate for steady state conservation systems, and the input rate is equal to output rate. So for this part of Unit 1, it's all about about the mass and energy transfer process in various interfaces. The next part is coming soon. Thank you.